Good morning to one and all. I am Parthivan, working as an assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called electron devices, which is coming under the regulation R 2025. The subject code is EC25C01. Now I am going to talk about the unit 3, which deals with the BJT, or we can also say bipolar junction transistors. So the main use of transistor, as I already told you, either it can be used as an amplifier or it can be used as a switch. But transistor as an amplifier is a very popular, so because it is very widely used and it is the origin of all amplifier design. There are namely three terminals are will be there. One is called emitter, base and collector. So they based on the common terminal, we can say either it can be a common base or it can be a common collector or it can be a common emitter. So based on the common, we can classify the transistor as a CE or CB or CC. So based on the input and output, we can classify in this way. So the three types of or three modes of operation of transistors are called common base connection, or it is a common emitter connection, or it is the common collector terminal. So based on the particular terminal that we are using as a common thing. So first we are going to talk about the common base connection. So here the base terminal is common for both input side as well as output side. That is why it is called a common base connection. So here the input is applied between the emitter and base and the output is taken from the collector and base. So this is a typical configuration of a CB. The base is used as a common for both input and output circuits. Hence the name that is called common base connection. In the diagram you can see the emitter base junction is a forward biased, whereas the collector base junction is a reverse biased. In the same way, either it is a NPN transistor or it is a PNP transistor. The first diagram shows the input-output connections for common base in the NPN transistor characteristics. The second diagram shows the input-output connections for a PNP transistor in the common base mode. So the input signal is applied between the emitter and base, whereas the output is taken from the collector as well as the base via a resistor. That is nothing but the collector resistor. Next, the important factor that is called the deciding factor also is nothing but the amplification factor. So how much the capability it has to amplify the input signal that is applied. So common base amplification factor is represented in terms of the notation called alpha. It is in the common base collection, the input current is emitter current and the output current is collector current. So the ratio between these two is called amplification factor. That is nothing but the alpha. So alpha is the ratio of change in collector current to the change in emitter current at the constant VCB, that is nothing but the collector base voltage, which is known as current amplification factor, or it is also called alpha. So generally the alpha value will always be less than unity. The ideal value we can say it will be around 0.99. That is also we can say the practically it will be less than that. So the alpha indicates the current amplification characteristics of the CB. So this value is very less in comparison with the other modes. So the for current amplification purpose we cannot rely on CB mode since the value is very less. Generally, the collector based junction is generally reverse biased, whereas the emitter based junction is forward biased. There will be always some leakage current that will flow due to minority carriers. So generally for calculating the total collector current, we have to take into account both the majority current as well as the minority current. So we have to include the leakage current also. So for calculating the total collector current, IC is equal to alpha IE plus I leakage also. So alpha is nothing but the current amplification factor. IE is the emitter current plus the leakage that is induced due to the minority carrier injection also. The next diagram that is depicted clearly shows the common base connection. Here you can see the emitter is kept as open. A small leakage current still flows in the collector circuit. So this leakage current is abbreviated as ICB0. That is nothing but the collector to base current, that is with leakage emitter open. That's why it is represented as ICB0. It is also called as leakage current. So this is diagrammatically represented in the common base connection. So this one is gives the exact representation of the common base connection with input as well as outputs. So the one with emitter open, the other with emitter biased. So these are the two cases, particularly for the NPN transistor we can have. In the CB mode, a small collector current flows even when the emitter is open or the emitter current is there. This is called a leakage collector current and it is denoted by ICB0 as I already told you. The next one is the complete representation, or we can say the practical connection for the common base in the input characteristics as well as the output characteristics. From this diagram, we can study the input characteristics of the CB mode as well as the output characteristics of the CB mode. You see from the here, from the emitter base junction, there is a voltmeter is connected, there is a ammeter is connected along with the variable resistor, along with the biasing, that is VEE, nothing but the emitter bias, which is in the reversed condition actually. In the collector base junction, you can also see there is a voltmeter is there is a ammeter is there is a variable resistor is there, along with the biasing, that is called VCC. So V is the nothing but the emitter bias, VCC is the collector bias. So by varying R2 and R1, we can able to vary the characteristics. We can able to vary the study the characteristics of CB. So under various resistances, we can able to measure the various values. So input characteristics is one, which is nothing but the variation between the two input parameters. For example, it can be between the base to collector voltage versus IE. So this indicates the input characteristics. From the input characteristic, we can able to measure the input resistance also, which is nothing but the Ri is equal to del VBE by del IE, keeping VCB as a constant. So this is the input side variations. So there are two parameters that we have to take into account on the input side. One should be the voltage, the other should be the current. If it is taken on the output side, then we can say it is the output characteristics. You see the characteristics variation of common base. So in the CB, the VEB is varied in, that is in millivolts, and the emitter current is measured in milliamps. You see it increases as VEB increases, generally the emitter current also increases. After that, it is going for a saturation point. So you see the variation for VCB is equal to 0 volts. You see the variation for VCB is equal to 10 volts. So it clearly depicts the higher the VCB, higher the emitter current. So these characteristics and all we can see. Similarly, we can also have the output characteristics. So the output characteristics is nothing but it is a variation between the collector current to the collector base voltage. So keeping emitter current as a constant. So we can also measure the output resistance, that is R0 is equal to del VCB by del IC, keeping IE as constant. So output characteristics, as I already told you, it's the variation between the two output parameters. So this diagram or this graph represents the variation of output characteristics of common base. So in the x-axis we see the VCB is taken in volts, whereas in the y-axis it is IC in milliamps. As IE is equal to 0, it will have minimum collector current. If you increase the value of IE, you see the variation of IC. So when IE is equal to 5 MA, we can have the maximum collector current. So this is the characteristics of common base. So these are the references I used to make the slide. So once again, thank you for hearing my lecture patiently. Thank you one and all for hearing my lecture.